Hello, today I am going to discuss about spectral lines with the support of other topics. So, to study the spectral lines, we need to study about the photon energy, atomic structure, and spectral lines and elements in stars by the cause of the spectral lines, masses of the stars, mass luminosity relations. So, first, let me go to discuss about the photon energy. Up to now, we have been discussing the wavelength of light as determining it by its color only. If we know the wavelength, we can know the color. However, light comes in discrete packets called photons, which is coming out from the atoms. And the energy of each photon is set by its color or wavelength. From Einstein's theory, we know that the photon energy is inversely proportional to its wavelength. That means here where E is equals to h nu, and we know that E is equals to hc by lambda. So this wavelength is decides the photon energy. So based on these Einstein equations, we can find the Einstein's relations wavelength with that. And now the photon energy, when the low frequency, then it's having the longer wavelength which produces the red color. And then similarly the shorter wavelengths of the color which gives the violet color, and it has the higher frequency. If we know the frequency is high, then E is directly proportional to nu. That means which are having the higher frequency, those are having the blue color. So this is the blue color frequency. And if you for going for the frequency is increases, and blue color is also very thick blue colors where we can observe. Let me come to the hydrogen atom. In this hydrogen atom, this part is the nucleus, which are gradually magnified relative to the electron cloud. This is the electron cloud. The electron cloud is containing the charges, and this electron orbits is having the first orbit and second orbit and third orbit and fourth, fifth, sixth. And these energy levels, here we can find that the difference between these two energy level is very high. But if you go for the higher energy levels, its differences are very less. And possible distances of the electron in the hydrogen atoms are very less, very high at here. And energy levels for the hydrogen atom. For quantum mechanically only certain orbits are allowed. Each orbit has specific energies. If you observe that this is a nucleus, inside of the nucleus, this is considered as first particle in first orbit, this is the second orbit, and this is the third orbit. If a collisions with moving charges, now this is the collisions. Now these atoms, while it is revolving in this, the collisions where happens, then the electron jump from the lower energy level to the higher energy level. And now the after sometimes the electron will be jumps from the lower energy level to the higher energy level to the lower energy level by the emission of photons. So this is the cause of the photons we are getting here. It is the light of the photon. How atoms emits the light means the emitted photon has an energy which is exactly the energy differences between the orbits that the electron had before and after. Either it is absorbed, then it will go for the lower energy level to the higher energy level, which is from E1 to E2 by the absorption. Now the energy is absorbed by the atom is E2 minus E1. So this is the energy which is absorbed by the atom in orbits. Now let me go for, because of only certain energies are allowed for the electrons orbits, that certain energies are which are equal for the energy difference. Only certain energies, that difference which are suitable, then the energy will be absorbed and it will be go for the higher energy levels, and it will be come back by the emission of photons. Now let me go for see the spectral lines of the hydrogen atoms. We know very well the spectral line of the hydrogen atoms, which are Balmer series and Paschen series and Brocket series and Lyman series, by the different energy levels in these passions. Now the spectral lines will produce, each element has its own particular set of energy levels and it's a set of spectral lines. The uses of the spectral lines is generally because of each element has its own unique pattern of the spectral lines. The spectral lines from the stars can be used to determine the composition or the relative number of atoms each atom and each element of the stars.